Welcome back in another video tutorial from microbiology with Isopicnic. So in our previous video tutorial about centrifugation, we have discussed about differential centrifugation. So our today's installment is all about differential centrifugation, density gradient centrifugation. Okay, so density gradient centrifugation is a just modification of differential centrifugation to achieve a better separation, purification, as well as we are using density gradient centrifugation to determine the molecular weight as well as the sedimentation coefficient and some type of physical properties of molecules also. That means density gradient centrifugation. In density gradient centrifugation we may find analytical centrifugation, because before that kind of centrifugation, the centrifugation procedure we have discussed, we have not found any kind of analytical centrifugation, right? We have found preparative centrifugation where just we are involved in separation of the particles from the rest of the mixture. But here we can also determine the physical properties such as molecular weight and other stuff. We are coming to this topic. That means density gradient is, in simpler word, is just used to make our centrifugation or separation process better than the previous one. Just a simple answer. Okay, so what is density gradient centrifugation? Remember, in density gradient centrifugation is nothing different. It is as simple as that there is a tube in which liquid medium is present, in which you have suspended your samples that you are willing to separate. Okay, sample mixture. Now here there is a twist. What is the twist? That the medium in which you are willing to centrifuge your sample is a, sorry, let me write it. So the idea, the twist here is, in the media in which you are willing to centrifuge your sample is gradually increases from the top to the bottom in its density. That means there is a gradient of density, right? Why? Because there is a gradient of increasing concentration of solute, which ultimately leads to increasing concentration of density. That is the idea. That is how, by using increasing concentration or increasing density of a solution or medium, we are separating our sample mixture at a higher level, right? That is the idea of density gradient centrifugation. So what is density gradient centrifugation? Density gradient centrifugation is a variation of differential centrifugation in which samples are centrifuged in a medium that gradually increases from the top to the bottom in its density, right? And here the gradient consists of the concentration of the solute, or the increasing concentration of the solute, I should say more specifically, from the top to the bottom. That is the density gradient centrifugation's definition. Now after that, the question is, what are the classification of density gradient centrifugation? So density gradient centrifugation is of two types. One is red zonal centrifugation, another one is isopicnic centrifugation. That is, I have written here, isopicnic centrifugation. So what is the differences in red zonal centrifugation and isopicnic centrifugation? The differences in the gradient. Okay, in case of red zonal centrifugation, the sample is centrifuged in a preformed gradient, and in isopicnic centrifugation there is a self-generating gradient formed during centrifugation. That means in case of red zonal centrifugation, the gradient is, we have to preform the gradient before the centrifugation procedure, but in case of isopicnic centrifugation, the gradient is self-generating during the centrifugation. That is the differences between red zonal and isopicnic centrifugation. And there is a short information that ultra centrifugation speed is excess 30,000 rpm and RCF here is over 60,000 6 lakh G. Okay, we have discussed that RCF, that is our relative centrifugal field, is represented in the multiplication or in multiplies of G, right? So that is why, so ultra centrifugation speed is excess 30,000 and RCF is 6 lakh G. So the main thing that is important in that slide, that what is density gradient centrifugation? Density gradient centrifugation is a variation of differential centrifugation in which the sample is centrifuged in a medium that gradually increases from the top to the bottom in its density, right? The gradient consists of an increasing concentration of solute from the top to the bottom. So here we have discussed two kinds of centrifugation, density gradient centrifugation, red zonal centrifugation, in which the gradient is preformed, and our isopicnic centrifugation, in which the gradient is forming during the centrifugation procedure. Now let's come to the first type of centrifugation. The density gradient centrifugation is the red zonal centrifugation. Remember here just the difference of red zonal centrifugation with normal kind of centrifugation is, red zonal centrifugation consists of a density gradient, okay, and the rest of the part is exactly same. Red zonal centrifugation separate particles based on their sedimentation rate, as just like other centrifugation procedure. Sedimentation rate means it separate particle based on differences in size and density. Although the red zonal centrifugation procedure, although the sedimentation rate is greatly influenced by size and density, red zonal centrifugation also influenced by a slight variation of the shape of the molecule. Why? Because remember, the shape is constantly is inversely proportional to the what? Inversely proportional to the frictional force, right? That means compact molecule will exhibit lower friction and extended molecule will exhibit greater friction, and friction play an important role in retarding the movement of molecule during the centrifugation procedure on the basis of their sedimentation rate, right? That is the reason size, density and shape, three factors equally play a vital role in red zonal centrifugation. And remember one thing, in red zonal centrifugation our focus is not sedimentation, okay? Our focus is just to separate our sample of interest into three distinct zones, okay? So that is why we have to centrifuge our sample just long enough to separate our sample mixture into distinct zones. If we use the centrifugal force much larger than necessary, then all the molecules will be pileted at the bottom of the tube, okay? So in that case the separation will not be performed, so we have to avoid it, okay? Now the thing is, what kind of gradient is used here and how the gradient is produced in case of red zonal centrifugation. So the material that is commonly used for red zonal centrifugation gradient production is glycerol, sucrose, and the third one is phycol. So for sucrose the concentration is 5 to 20%. Remember, most of the cases 5 to 20% sucrose concentration is used for red zonal centrifugation. This is also important for MCQ part also, okay? And now the question is, why density range is mentioned? Because we have to prepare our gradient in such a way that the gradient's density should not be higher than the density of the particle at any point of separation, okay? Otherwise the particle will not centrifuge, because we have discussed at our very first video that if the particle's density is lower than the medium's density, then it will not sink, instead it will float due to the presence of random thermal motion, and in that case the sedimentation of that particle will be very difficult. We have to apply much centrifugal force in such cases, and that is not a good task, right? Because here we are willing to separate our sample into 3 distinct zones. So if we use sedimentation force at a higher amount than required, it will disrupt our result or our actual goal of red zonal centrifugation. Okay, so that is why we have to prepare our density gradient on the basis of the density range that is usually preferred. Here I have discussed that sample are centrifuged just long enough to separate the molecule interest into discrete zone. If a sample is centrifuged much longer than necessary, all the component of the sample will end up in the pellet at the bottom, and which is not needed in that case, right? Now the question is, what is the function of red zonal centrifugation? So red zonal centrifugation is used for purification, preparation of the macromolecule. Not only that, it will give you the molecular weight as well as sedimentation coefficient of the molecule. Okay, let's see how. Suppose in that tube there is a purified protein and this tube is spun in a centrifugal force. Okay, that means under the centrifugal field the molecules in the tube will sediment towards the bottom of the tube at a constant velocity. So under such condition, the molecular weight of that protein molecule that sedimenting towards the bottom of the tube will be Fv by omega square r. So that is the formula for determining molecular weight. Not only molecular weight, but it also give you the sedimentation coefficient, because V by omega square r is present. So our formula for sedimentation coefficient will be V by omega square r m by f. Okay, that means molecular mass, molecular weight of the protein by the f, that means our frictional coefficient. Okay, and we all know that frictional coefficient is depend on the size and shape of the molecule and the density of the medium. Okay, so with the help of that condition we can easily determine the frictional coefficient. Not only that, we have also the net force formula to determine the frictional coefficient, because we all know that frictional force is equal to net force in steady state condition during centrifugation, right? If you have forgot, let's revise this. Sorry for that. Vf is equal to m omega square r. Sorry, the formula was Vf is equal to m omega square r 1 minus v bar rho. I hope you remember. Then from the, if this value is available to us, then we can easily find out the frictional coefficient. Okay, so that's it for today, guys. We have discussed today about the red zonal centrifugation. Now let's look at that picture. We are just willing to do this kind of thing. Okay, that means the entire sample will be separated into 3 distinct zones. That is the basic goal of red zonal centrifugation. Here we are just willing to increase the purification, right? And along with it also give us the molecular weight and sedimentation coefficient, so that we can conclude that this kind of centrifugation is an example of analytical centrifugation. MCQ may claim that they will give you the centrifugation name, and you have to tell what kind of centrifugation is an analytical centrifugation. So you have to tick in such case on red zonal centrifugation. Okay, so I hope that you have understood well what I am trying to discuss with you, and thank you for listening to this class. In the next video we are going to discuss about the second type of centrifugation, density gradient centrifugation, in which the gradient is self-generating during the centrifugation, that is isopicnic centrifugation. After that we are going to discuss about the equilibrium density gradient centrifugation, where we will separate the DNA molecule with the help of cesium chloride. That is a very famous method we are going to discuss in our upcoming videos, and then we will move on the last topic of centrifugation, that is ultracentrifugation. So I hope you are enjoying my lectures and also understood the concepts well. So till then, bye bye.